Yes, welcome to Easy Gates Gate 22 ECE Solutions. Let us get into the next problem. This one from control systems. Probably it's an MSQ problem. That's how I remember. So two different systems are given. In what aspects they are different, you'll come to know only when you compare it with a standard model. What is the standard model? A standard second order should be given with a static sensitivity K and its natural frequency omega n as K into omega n square by a square plus 2 zeta omega ns plus omega n square. Okay. Either you can pronounce as zeta or eta, that's fine. Okay, so that's damping. So we have three parameters. One is K, that is your static sensitivity, omega n, that's a natural frequency, and eta or zeta, that's your damping. Okay, so these three factors only determine or talk about the character of the second order system. So now what is given is when excited by a step input, system 1 and system 2. So what they will do, excited by a step input. So two systems are given. One is 10 by s square plus s plus 1. Second system is 1 by s square plus root 10 s plus 10. And they have different omega n. So you have to compare the standard model. So this is standard model. You have to compare the standard model. So what is a K means you can find for system 1. System 1, let me take this way. System 2 this way. System 1. Its K means if you want its static sensitivity, it's a better route. So let s equal to 0 in this, you will get K. So put s equal to 0, the static sensitivity for the first system is K is equal to 10. And the second system static sensitivity is 0.1. Let me check once. Okay, 1. Let me check the data once. Yes, a small change in the data. This is 10 instead of 1. Yes. Yes, this is exactly the problem. Yes, what is K in the second case means it is not 0.1. That's where I got the doubt. Okay, it is not 0.1, it is 1. So system 2 is having a static sensitivity of 1. System 1 is having a static sensitivity of 10. Okay, then what about omega n square? So this omega n square is 1. This omega n square is 10. That means system 1 will have omega n is equal to 1, whereas system 2 will have omega n is equal to root 10. Then you have to compare the 2 zeta omega n. So 2 zeta omega n is equal to 1 here. Here it is 2 zeta omega n is equal to root 10. So from this, omega n itself is root 10 means these two will get cancelled. Therefore, zeta is equal to 0.5. It's under damped system. And here omega n is equal to 1. So therefore, it is 2 zeta. So that means 2 zeta equal to 1. Here also zeta equal to 0.5. That means the two systems are identical with respect to the damping. See, the beauty of the problem is it's an MSQ, multiple select. That's how I remember. Okay, so MSQ means usually we expect more than one options, correct? But we'll see what is correct in this. So zeta equal to 0.5, zeta equal to 0.5. That means the two systems are identical in terms of damping means when excited by a step input and both will produce identical overshoots. Okay, only overshoot depends on damping. Then second choice. Okay, let me take a different color. Yes. So this is true. Then what about the second? Produce identical steady state responses. Identical steady state responses means it is going to be your step size into the static sensitivity will be the final output response. It's talking about the steady state output response. AK will be the steady state output response. A is the step size, that is 1 in this case, and K is the corresponding sensitivity of the system. So system 1 has K equal to 10 and system 2 has K equal to 1 means therefore they will definitely settle at different final values. Okay, so steady state responses are not identical, so this is wrong. Then what about the next one? Identical settling times for TS, 2%. 2% tolerance band settling time is identical means. And what is TS? TS depends on TS for 2% tolerance band is approximately 4 by zeta omega n. That means they should have identical zeta omega n. But when you compare here, so it has 2 zeta omega n equal to 1. So this as zeta omega n is equal to zeta omega n itself is going to be 0.5. And how about this zeta omega n? This zeta omega n is equal to 2 zeta omega n is equal to root 10, and zeta omega n will be root 10 by 2. So they have unique. This is greater than 1. Root 10 by 2 will be greater than 1. So therefore, this is different. This is different. Therefore, they don't have identical zeta omega n means definitely they will have unique settling times. So identical settling is not possible. Okay, unique settling only possible. And what about the final point? They have identical, the two systems excited by a step input will have identical damped frequencies. Identical damped frequencies means omega d. So what is omega d as per the fundamental of second order transient time domain transient response of a control system? Omega d is omega n into root of 1 minus zeta square, damping square. Yes, omega n are unique. They have different omega n. Therefore, since omega n are unique, even though identical damping, definitely system 1 will have omega d1, system 2 will have omega d2, and they are not equal. Therefore, this is also failing. Okay. I still feel this is an MSQ problem given, but having only one option correct. Yes, the correct answer is only option A. Okay, so maybe in your problem, your option may not be A, maybe placed somewhere else. Accordingly, you have to give the answer. So as of now, it has only one option that is correct. So for the given options, only A is correct for this problem. Okay, that's an interesting problem. Comparing step responses of two underdamped system, they have identical underdamped condition, so only overshoot can be identical. Rest of them are non-identical because they have unique static sensitivity, they have unique natural frequency. Okay, that's a reason. That's a very simple problem. Okay, it's not a complex one demanding huge thinking. Okay, so for someone even an ordinary, that means one who normally prepared control system also will connect for this problem. Okay, yes, we'll update you with one more problem. So thank you.